Hello students, so today we're going to look at how to define general angles and use radian measure. Trust me, it's not as hard as you think. What you're going to want to have, a calculator, your notes, and of course something to write with so you can actually write in the notes. So, angles in standard position. You've heard of angles before in geometry, so we're going to apply that now to sine, cosine, and tangent. So each angle has an initial side and a terminal side. The initial side is of course at 0 right here. So it's always going to start right here, the positive x-axis. And the terminal side is where that angle is done sweeping out. Angles in standard position have a vertex at the origin, so right here, and its initial side is the positive x-axis. So it's going to be right here. That's where the positive x-axis is going to be. So we're always going to want to start sweeping it out there, from there. So positive and negative angles. You can have negative angles. You don't think about it, but now you actually can when you have this two-dimensional plane. The measure of an angle is positive if the rotation of its terminal side is counterclockwise, aka are you going from, if I have my x-axis right here, if I'm going that way, okay? It's negative if your rotation is clockwise. So if I'm going from here and I'm going that way, that's going to be a negative rotation. Now, angles can be formed by going around more than once. I could have a 45-degree angle right here, okay? If I go around one more time, I actually am going to make another angle. Theoretically, it's still 45 degrees, right? But if I go all the way around, I'm actually a different measure of angles. We'll take a look at a few of those today as well. So, drawing an angle with the given measure in a standard position. These are a little difficult to think through. You need to figure out where would 65 degrees be. So here is my 0, here's my 90, here's 180, and here's 270. That's how it's always going to be set up. So 0 and 90 is where 65 is going to lie, and it's going to be closer to 90. So it's not going to be in the middle because that's 45 degrees. So it's kind of going to be in the middle of those two, so about right there. So I'm going to put an arrow and show that I'm sweeping from 0, 0, my initial side of 0, all the way to 65 degrees. And I don't need to put a 65 in there. I will just show that I'm sweeping out to that. 230. Now, same thing. I have a 0, I have 90, I have 180, and I have 270. I know that 230 is between 180 and 270. Now, halfway between those two would be 225 roughly. So I know I'm going to be close to being half. So I am going to be right about there. But now I need to show that I swept from there. So I'm going to put in a line there, go all the way around, and put an arrow saying that's where I'm ending up. So I started at 0, swung all the way to 230 degrees. What about negative 300? Now, a few of you are thinking, holy buckets, negative 300. Don't worry about it. You're going to start here and think opposite. So this is going to be 0, negative 90, negative 180, and negative 270. Okay? So now, if I sweep to 300, that's going to be 30 degrees off of this, right? So it's going to be roughly right there. Follow me so far. So now, I'm not sweeping from here to there, though. That's not 300 degrees. I went negative, so I'm going to sweep all the way around and put an arrow to point to there. That is negative 300 degrees. Now, 740. We're thinking, holy buckets, that's really big. Well, I'm going to find out how much that would actually technically be. So if I start here and I sweep all the way around, get to there, I have made a 360 degrees, right? So from my 740, I now still have 380 left to sweep. So I'm going to go around one more time, like that, and I have now only 20 degrees left to go. So then I'm going to draw my 20-degree reference angle, which is roughly about right there, and finish the rest of my spin. Whoops. So I went around twice to get to 740. That's why I have my angles, my spinning there to show that I went all the way around. Now, notice how 740 has the same angle as 20 degrees, same terminal side, right? Well, coterminal angles is what that means. Angles whose terminal ending sides coincide, aka they're the same. To find these, basically all you have to do is add or subtract multiples of 360. It's really super simple. So if I need to find a positive angle and a negative angle that's coterminal with, let's say, 65, I am going to first add 360 to 65. It's going to find one of my angles. Add those two, I get 425. That's one of my angles. That's my positive angle. Now, I need a negative. To do that, you're just going to subtract 360. And you're going to get negative 295 degrees. Pretty simple, right? Either add 360 or subtract 360. So 230, I'm going to do the same thing. I'm going to add 360. I'm going to get 590. And to find my negative, I'm going to subtract 360. It's always going to be 360. Okay? Negative 300. This one's going to be a little different. So I'm going to add 360. You're just going to get 60, right? Negative 300 plus 360, that's just 60. Now, if I subtract that, I'm going to get negative 660. I found a positive, but I found a negative. Pretty simple. So either add 360 or subtract 360. Now, you could continually add 360 and you would get many positive angles. You could continually subtract 360 and get multiple negative angles. So really super simple. Converting between radians and degrees. Now, we did that thing about radians today in class. Radians is a measure of an angle that cuts one radius's worth of the circle. Now, to convert, a lot of us, we think more in degrees than radians, just because we're wired for degrees more. And so what's what we're comfortable with right now. So to convert, you're going to set up a proportion, aka two ratios equal to one another. So you're going to go degrees over 360 equals the number of radians you have over 2 pi. So however many degrees over 360 equals radians out of 2 pi. Why 2 pi? That's how many radians are in a circle. Just like 360 is that many degrees in a circle. So let's convert 120 degrees to radians. So we're going to set that up. I have degrees over 360, so 120 over 360 equals x over 2 pi. All right. Multiplying across, I'm going to get 2 times 120. I'm going to get 240 pi. Just leave that pi there. Just let him sit there, okay? Equals 360x. Solving for x, because that's what we want to solve for. Divided by 360. So 240 divided by 360. If I simplify that down, you should get 2 over 3. And that pi is just going to stay there. So 120 degrees is 2 pi over 3. And that's in this video. See you later, Sabers.